Okay, now it's time to talk about the intestines. We've already talked about esophagus and stomach here. So at the top we have esophagus. This is where we had our cardiac sphincter up here, allows food into the stomach. From the stomach, the pyloric region of the stomach leads into the small intestine here, where we had the pyloric valve. The pyloric valve here. Extending on beyond the pyloric valve, we have the first segment of the small intestine, indicated by this color. That's the duodenum. Sometimes called duodenum, sometimes called duodenum, but we'll call it duodenum. It leads into the next segment of the small intestine called the jejunum. The jejunum leads into the third segment in red here. This is the ileum. The first segment, the duodenum, is only about 10 inches long. The second segment is about 3 feet long. The third section is about twice that, about 6 feet or more long. The ileum is the longest part of the small intestine. A short distance down the duodenum here is an opening, sometimes referred to as a duodenal papilla. It's a little bump-like spot with an opening in the middle. It's the opening to the hepatopancreatic ampulla. The hepatopancreatic ampulla empties in through that opening at the duodenal papilla right there. We're going to look at what goes on in the small intestine on the inside in detail here in a minute. I'll mention here at this point, at the very end of the small intestine, right here, it leads into the large intestine. So this is the large intestine across here. That opening right here is controlled by a valve. There's a valve at that point called the ileocecal valve, right here, that regulates the movement of food from the small intestine into the large intestine. So we've got two valves, one at either end of the small intestine, the pyloric valve up here and the ileocecal valve down below over here. So now let's talk about some of the details regarding these segments of the small intestine. First of all, the duodenal portion, the first segment, is different from the other, not from the outside, not from what you can see on the outside, but in the wall of the intestine, in that submucosal layer. The duodenal portion, the duodenum, has some special glands called Brunner's glands in the wall of the duodenum. The jejunum and ileum lack those submucosal glands, those Brunner's glands. Next, the ileum in here differs from the jejunum in that the ileum has those Peyer's patches that we talked about earlier. These are groupings of lymphatic nodules that occupy the mucosa and submucosa layers, the lamina propria portion and the submucosal portion. These are large lymphatic nodules that are in groups called Peyer's patches that you find all along the length of the ileum of the small intestine. So Brunner's glands in the duodenum, no Brunner's glands or Peyer's patches in the jejunum, and then when you get to the ileum, you have the Peyer's patches all the way through to the end. We'll go ahead and do some labeling now on our diagrams. We haven't done any of that. First of all, beginning right here, we want to remember that this is our pyloric valve. Between the stomach and the small intestine, the first segment of our small intestine here is the duodenum. Next, our duodenal papilla. That's the connection to our bile duct and our pancreas, our hepatopancreatic ampulla, or entry point right there. So that extends through this segment in this darker purple color here. We have the jejunum. Then in the red over here, all of this is the ileum, I-L-E-U-M, the ileum portion of the small intestine. At the very end of that is the ileocecal valve. Now, a couple of notes about some adaptations of the small intestine to increase absorptive surface area. So your food molecules are being broken down as they move through the small intestine. Enzymes and such are going to be added to the mixture from both the intestine wall and from the pancreatic secretions. So you're breaking down these food molecules chemically. They need to be absorbed across the surface of the cells that line the intestine. So to increase the absorptive surface area, the total area that those nutrients can be absorbed across, we have 4 different adaptations. The first one is what we call plicae circularis. Those are also known simply as circular folds. Circular folds. That's the first one. Plicae circularis. Plicae circularis, or circular folds of the small intestine. Curtain-like folds that come in from the wall. They run transverse, kind of like the little lines I have here, that kind of come in from the wall. They don't extend out very far in toward the lumen of the intestine, just a little ways. But anyway, those increase the absorptive surface area, just having all those folds along the wall. Secondly, it's just really long. So we have a very long intestine. That adds to the overall absorptive surface area. Thirdly, we have the villi of the intestine, these tiny little projections, finger-like projections that cover all those surfaces of all the circular folds in the walls of the intestine. So villi in the walls of the intestine. And fourth, each individual cell, so if this is an individual cell here, on the surface of that cell, it has what we call microvilli, little extensions coming up off each cell to increase that absorptive surface area. So each cell has a whole array of very evenly sized and spaced microvilli. So those 4 things increase the absorptive surface area for food molecules in the small intestine. Now, before we leave the small intestine, I'm going to make one more drawing that shows the a segment of the length and the layers of the small intestinal wall. Another thing to remember is that all of these segments of the small intestine are surrounded to some extent by mesenteric membrane that comes out from the wall. So it forms a serosa around the organ, and then a sheet of mesenteric connecting membrane runs between the dorsal body wall and these loops of the intestine. If you were to pull the intestines out, when we do the cat dissection, we often see this. We can lift the intestines up and see suspended between these loops is that thin sheet, a transparent sheet of a membrane that extends between the organs and the dorsal body wall. So next, let's go ahead and draw a segment of the small intestine showing the layers of the intestinal wall. Okay, there's a image on the computer website that looks like this. I'll try to go through this with another drawing on the board. It looks very similar. Now, I've tried to recreate that image from the website here on the board. It's not going to be quite as good, I don't think. But anyway, all of the pink on the inside, that represents the inner surface. That's that epithelial surface of the mucosa, the mucosal lining here in pink, and it's thrown into folds. The inside of the small intestine is going to look very wrinkly. So I've tried to draw these folds in here, and you can see some of them where we've cut through the wall here. We see parts of those folds coming in. So we have the mucosal surface on the inside, and mucosa thrown into those folds. Some of the submucosa, which I have in orange here, comes into those folds. So those folds, those circular folds of the small intestine, have a core of submucosa inside of them, a little bit of submucosa coming into those folds from beneath. Now, if this is duodenum, there will be Brunner's glands in that submucosa zone. If it's the ileum, it'll have lymphatic nodules, at least on one side of the intestine, in that submucosa zone. Outside of that, we have two layers of smooth muscle, an inner circular layer and an outer longitudinal muscle. Here I've stippled the circular muscle here on the inner layer, and the longitudinal muscle going up and down is solid here. Where we've cut through it going the opposite direction, I've stippled the ends of your cells in your longitudinal muscle, and you see the long section, the solid, of the inner circular muscle layer. So we have an inner circular layer and outer longitudinal layers of smooth muscle in the wall of the small intestine. Finally, the last layer, the outside layer, is the serosal membrane. Remember, the serosa consists both of a bit of connective tissue, vessels and nerves and such, maybe even some adipose on the surface of the muscle, outside of the muscle. And then on the very outside, the very surface, would be a covering of mesothelium, simple squamous epithelium cells making up a mesothelium. Now, I was mentioned a minute ago that there would be a mesentery connecting membrane that reaches out to the intestine. So this outermost layer right here would reflect back to the dorsal body wall as a sheet of membrane back in here. So this would be the membrane that reaches out to the intestine from the back body wall, the mesentery of the intestine.